All right, good afternoon, everyone. So can you all hear me okay? Good. Okay, well, I'm just going to sort of start with a broad overview addressing, the question, what is fermentation anyway, and why is it significant? And then I'm going to try to sort of, get through this relatively quickly so that we can be more interactive and, I can hear, what kinds of questions might be on your minds. So broadly speaking, fermentation is the transformative action of microorganisms. If you have a biology background, you might already be shaking your head. Biologists definitely use a more specific definition of fermentation. For a biologist, fermentation is the production of energy without oxygen, anaerobic metabolism. And indeed, most of the most widespread ferments, involve anaerobic metabolism. The production of alcohol from sugars does not require oxygen. The production of sauerkraut is anaerobic bacteria. But there are also, certain foods and beverages that are created by the transformative action of microorganisms and are universally regarded as ferments, and yet they require oxygen. So some examples of that would be vinegar, kombucha, tempeh. And because these are always regarded as ferments, I prefer to work with a broader lay definition, that fermentation is the transformative action of microorganisms. But of course, not every transformative action of microorganisms results in something that we want to put into our mouths. I mean, almost all of the food that we discard, we're discarding because of the transformative action of microorganisms, because it has rotted, it has spoiled. So usually we reserve, mic check. Usually we reserve this word fermentation to describe microbial transformations that are intentional or desired. Fermentation is practiced universally. I mean, I certainly don't have, comprehensive information of every culinary tradition that exists on this earth, but I've been looking really hard for the last 15 or so years for a counterexample. For an example of a culinary tradition that does not incorporate fermentation. For a long time, people would always tell me that the Aboriginal people of Australia had not developed any fermentation methods. And then when I had the opportunity to go to Australia, I went on what they call a bush tucker, a wild foods walk. And the first nut that this Aboriginal guy picked up to talk about was something that is poisonous if you eat it straight out of the shell. But the way they make it edible is that they soak it in water, and when you soak any dried food in water, it initiates a fermentation and detoxification. Breaking down toxic compounds into benign forms is one of the reasons that people around the world ferment. So right there, the first item that the Aboriginal guy pointed out was something that ferments. People have been practicing this, for millennia before, anyone identified particular microorganisms. I mean, it was only Louis Pasteur about 150 years ago that first began to, isolate and identify specific microbial agents of fermentation, and yet people have been practicing this, with intentionality, in every part of the world for thousands of years. Now, the reason why I believe that fermentation is practiced all around the world is simply that microbial transformation of our food is an inevitability. As long as people are hunter-gatherers, spending each day procuring the food resources to get them through that day, they don't have to think too much about the dynamics of how food, ages as it is stored. But once we begin to move away from hunter-gatherer lifestyles to settled agricultural societies, well, in order to meaningfully invest our energy into crops that are ready at a certain moment of the year, we have to have some, some insight, some strategies for effectively, storing our food, those crops that are ready at certain moments of the year, to get us through the rest of the year. So in a way, agriculture doesn't make any sense without fermentation. Not that fermentation is the only means by which people have been able to effectively store food, but it has been one of the very, important ways that people have been able to store food. And, preservation is, let's say almost the most important motivation that people have to ferment food. I say almost because alcohol is certainly the most widespread form of fermentation, and with the exception of places where it has been specifically prohibited, and really not even with the exception of those places, it is practiced everywhere. People learned how to ferment sugars into alcohol. Now, in the literature of fermentation, there's a huge amount of speculation about this. How did humans invent this process? How did humans discover this process? Well, humans certainly didn't invent this process. I mean, the cells of our bodies are capable of fermentation. Fermentation is a natural process. Berries, fruits spontaneously ferment. There's a lot of documentation that, all sorts of, insects, birds, and animals are drawn to the smell and the flavor of fermenting fruits. There's even documentation of animals gorging themselves on fermented fruits and becoming disoriented, inebriated. So, rather than discovering, fermentation, I think we can assume that our primate ancestors were already somewhat familiar with this process, and when it was available, they would gorge themselves on fermenting fruit and, experiencing the alterations that creates. But what's really the specifically human cultural innovation with regard to fermentation is figuring out how to make it happen on our own terms, so we don't have to wait until berries, till fruit falls and gets bruised and starts to ferment or become overripe, on the vine. And a big piece of that is the technologies that we've developed for vessels. You can't ferment a liquid if you don't have anything to hold it with. So the vessels that we've created actually are a huge piece of how human beings have been able to make fermentation happen on our own terms. Alcohol has been regarded as a sacrament in some of the major world religions. In indigenous cultures all around the world, there is sort of ritual organized around both the production and the consumption of fermented beverages, and they have been just very, very important for many reasons. Beyond alcohol, preservation has been critically important reason for fermenting. I mean, in many parts of the world, people just could never have settled, couldn't survive without fermentation. In the far northern reaches, people who live up above the Arctic Circle, where waterways are only accessible in certain parts of the year. In the summertime, they catch lots of fish, and they mound those fish, and they ferment, and they freeze, and they thaw, and they ferment, and they freeze. And that is the practice that has enabled people to ferment, to exist, to survive in that region. In less extreme temperate regions with short growing seasons, fermentation is what has enabled people to have access to vitamin C through the long winter that doesn't have fresh plant food. With regard to highly perishable foods like milk and like meat, fermentation has enabled people to turn them into more stable forms, to feed them over longer periods of time, to transport and exchange them. The preservation value of fermentation, has been just critically important. I wish I could tell you that I got interested in fermentation, sort of primarily for the, utilitarian practical value, but I was drawn to fermentation as a kid by the flavors of fermentation. And, fermentation creates strong flavors, and, they're not always flavors that everybody can agree on, but if you walk into a gourmet food store and look around and think about the nature of foods that we elevate onto this pedestal, almost all of them are products of fermentation. As I mentioned, not everybody always agrees on all of the flavors of fermentation. So, I think we can get some insight into this in the realm of cheese. So, how many people in this room could identify with the statement, I love stinky cheeses, and the smellier they are, the more interesting I find them? Okay, so, even in this self-selected group, that is a minority. So, not everybody loves the smell of the strong, or loves the strongest kinds of cheeses. These are definitely acquired tastes. Nobody is born loving them. If we think about fresh versus rotten as sort of this notion that we all have to learn as small children, as our parents are teaching us, what is appropriate to put in our mouths, what isn't appropriate to put in our mouths. Sometimes it's really clear that something is rotten and you need to discard it. You can certainly tell when something is fresh and beautiful. But, fermented foods are neither fresh nor rotten, although in certain cases, like the stinky cheeses, many people would regard them as rotten. So, if I buy a beautiful chunk of stinky cheese and bring it home and invite some friends over to share it with me, some of my friends will share my passion for that. And then other people will, they'll come to the door and I'll open the door and they'll smell the cheese and they might say, what died in there? So to them, it smells rotten. It smells like decomposition. And all around the world, there are foods that, that people love. But that people from, sort of outside that cultural context, if they encounter that smell, that flavor for the first time, it reminds them too much of rotting. And it's just, it's too scary for them. And as a result of that, it can almost become, a marker of group identity, like that people within the group can love a flavor so much, and their love of it is almost enhanced by the fact that people outside of the group, find it so inaccessible. Frequently people want to know, like, where is that line between fermented and rotten? And really, there is no simple, objective, sharp distinction between food that is rotten and food that is fermented. And there's just a huge amount of cultural subjectivity to that. And just, a lot of it is, what you have become accustomed to. So fermentation creates strong flavors, and most of us find them compelling. I mean, I don't believe that there is, sort of anybody who doesn't like any kind of fermented food, particularly when you get into the realm of condiments. I would say fish sauce is the mother of all condiments. I mean, in many coastal areas of the world, fermenting fish that were too small to eat with salt is an ancient condiment. Certainly in the Western tradition, in ancient Rome, a fish sauce very similar to the ones that we find in contemporary Southeast Asian cuisines, was the predominant condiment. Our word ketchup comes from an ancient Chinese word for fish sauce. Soy sauce is another example of a fermented condiment, but our contemporary ketchup, mustard, mayonnaise, hot sauce, all of these are stabilized with vinegar, which is a product of fermentation. So all of the flavorings that people love to use to embellish their food, are based upon fermentation. Many people are getting interested in fermentation for perceived health benefits, and fermentation transforms foods in a number of ways nutritionally. One is predigestion, another one I would call nutrient augmentation, another I would call detoxification, and then finally live bacterial cultures. Predigestion is the idea that dense compound nutrients actually are digested before we eat them by the microorganisms that are fermenting the food. I think that the most vivid illustration of this would be soybeans, renowned for their protein density, in fact, generally regarded as the plant source food with the most concentrated protein, which is why the vegetarian subcultures of the West, embraced soybeans as an almost singular replacement for milk and for meat. But the Asian cultures that pioneered soy agriculture never eat just plain cooked soybeans. If you want to have an interesting experiment, try soaking some soybeans and cooking them for 6 hours and then eating a big bowl of them for dinner. And then you'll understand why people don't do that. Our human digestive systems are not capable of extracting that dense protein out of an unprocessed soybean. And so, in the parts of the world where soybeans emerged, they developed all these different ways of fermenting the soybeans. And the soy ferments are extraordinarily varied, from soy sauce to miso, to tempeh, to natto. If you know all of these foods, they're very different from one another in flavor and texture, but their commonality is that the protein gets broken down into amino acids by the fermentation. Amino acids being the building blocks of proteins. And by virtue of that predigestion, the soy nutrients become much more bioavailable to us. Similarly, lactose that so many people have a hard time digesting gets broken down by fermentation. So predigestion, which improves nutrient availability, is a really important transformation that fermentation can bring to different foods. Nutrient augmentation, beyond the predigestion, fermentation can contribute additional nutrients. Pretty much across the board, fermented foods have higher levels of B vitamins than the foods that we begin with. And then there are also these unique micronutrients, which are basically metabolic byproducts of the organisms that are fermenting the food. And some of these, have been found to be quite therapeutic to humans. So, for instance, fermented vegetables, sauerkraut, kimchi, fermented pickles, things like that have these compounds called isothiocyanates, which are regarded as anti-carcinogenic. They help prevent the kinds of mutations that can lead to cancers. Natto, the Japanese soy ferment that has never really gained traction in the West, has this compound that is mostly known as natto kinase, which has been found to help dissolve fiber accumulations in blood vessels. And it's available in vitamin supplement stores throughout North America, and being used, by people with, at risk for arteriosclerosis and other such conditions. Detoxification, I guess I mentioned in relation to the to these Australian nuts, but it's an application of fermentation that's used throughout the world, and it's the idea that the predigestion can break down certain compounds that can be toxic into benign forms. And sometimes the food toxins can be pretty dramatic, as for example with cassava. Cassava grown in certain soils has extraordinarily high levels of cyanide that could kill people if they tried to eat unprocessed roots. And so, the simple way of removing the cassava is to chop it up and soak it in water, initiate a fermentation that breaks down the cyanide into benign form and renders the cassava safe for people to eat. Not all toxins are quite so dramatic. Oxalic acid can be removed from food by fermentation. Phytic acid, which is found in the outer layer of seeds. You could eat phytic acid for years and not, recognize that it's toxic. What's toxic about it is it binds up minerals and makes minerals not available to us. And so, through a relatively short soaking fermentation, predigestion of fermenting organisms can break down those phytate bonds with the minerals and make the minerals in the food bioavailable. And then finally, the live cultures. Like all the things I've just mentioned, they are true of ferments whether they are cooked or whether they are not cooked. But the live cultures, fermentation cultures can include a wide array of bacteria and or fungi. But when we talk about the beneficial live cultures, we are really mostly talking about bacterial cultures rather than fungal cultures. And fungal cultures, can be benign for us to eat, but I've never read any suggestion that they are specifically beneficial. Whereas the bacterial cultures, most notably the lactic acid bacteria, are beneficial to us. And, human beings have a very intimate relationship with lactic acid bacteria. As a matter of fact, women's bodies produce a glycogen, a carbohydrate that specifically supports a population of lactic acid bacteria that creates an acidic condition that allows us to effectively reproduce. So, beginning with our reproduction, we are dependent upon bacteria. And then when babies are born, when they're fetuses in the womb, they are in a sterile environment. But, as soon as they are being born, they are being cultured. They are being exposed to bacteria. Prime among them, these lactic acid bacteria that their mother's bodies are specifically supporting. We have been, indoctrinated over the last decades into the misguided notion that bacteria are our enemies. That bacteria should be eradicated, that the only good bacteria is a dead bacteria. And I think that the most, vivid reflection of this, current in our culture is antibacterial hand cleansing soaps. I mean, is there anything sexier that a soap manufacturer could write on a container of soap than that it kills 99.9% of bacteria? I mean, I really have no idea whether these are as widespread in Canada as they are in the United States. But institutions and households, everywhere in the United States are being seduced into the idea that they're safer by washing their hands with soaps that have antibacterial chemicals. And yet when I ask groups of people, do you really think that, do you observe that fewer people are getting sick because everyone's washing their hands with these chemicals? It just kind of makes people smile and laugh, because it's absurd. Like, clearly fewer people are not getting sick. And, in fact, in the U.S., the organized voice of opposition to the widespread, consumer use of antibacterial cleansing products is the American Medical Association, because what they're doing is making those products less effective in the contexts where they are appropriate, such as for, people going into a medical into surgery that are sort of about to be inside of an incision in somebody's body. So they're less effective in the places where they're appropriate. But anyway, our bodies are kind of these battlefields in the war on bacteria, and between antibiotic drugs that as individuals we might take for very important reasons, but they're wildly overprescribed among the human population, and more so than among human beings. Animals in confinement agriculture are just pumped up with, vast amounts of antibiotics, and so there's residue from that, not only in meat and in milk, but in our water. It's just, the levels of, antibiotic compounds and other pharmaceuticals are accumulating in our water table. So, we're all ingesting antibiotics every day, plus the antibacterial cleansing products, plus the chlorine that's put into water precisely to kill bacteria. So, every day we have this exposure to these antibacterial chemicals. Historically, nobody had to think twice about, replenishing the bacteria in their bodies. But, for us living in the 21st century, because we have this daily chemical exposure, it's become more important than it has in the past. Bacteria are important for, every aspect of our functioning, not simply our ability to reproduce. We can't digest food effectively or assimilate nutrients without the bacteria in our gut. They synthesize certain essential nutrients for us. And they play a huge role that is only crudely understood in what we call our immune function. But in 2012, there was some research published that demonstrated that when you have an infection in your lung, when you have bronchitis, and your body mounts an immune response, which amounts to, sending white blood cells to, basically isolate and surround and digest away that infection, that white blood cell response in our bodies is mediated by bacteria in our gut. Another exciting new frontier of research so far in the context of mice is that the production of serotonin, that has such far-reaching implications for how we think and how we feel in our brains, is mediated by bacteria in our gut. So there's this big disconnect between the sort of ideology that we're all learning that bacteria are bad and the reality that the cells of our bodies are actually outnumbered 10 to 1 by bacteria that we're host to, and that these bacteria provide so many critical functionality for us. One way that people replenish gut bacteria is with little capsules that are called probiotics. And certainly a huge amount of research has documented the efficacy of different specific probiotic strains. Really for every aspect of human health. Not nearly as much research has been done with food. I mean, who's going to invest in clinical trials for sauerkraut? Nobody owns sauerkraut. But the little bit of research that I've come across looking at traditional foods suggests that they are actually even more effective probiotics than, little single strain capsules. The most interesting research that I found was done by a team of Spanish researchers, and they recruited a group of people who were already enthusiastic lovers of fermented foods, people who ate at least 5 servings a week of varied fermented foods, including sauerkraut, olives, cheeses, yogurt, salami. They cast their net pretty wide. And what they did is they did some baseline blood work for their volunteers. And they were looking at immune globulin and a range of other indicators of immune function. And then they put everyone on a deprivation diet where they couldn't eat these fermented foods for some weeks. And then at the end of their period of deprivation, they did more blood work. And they found that, the average level of all these indicators had been suppressed, basically by the lack of bacterial stimulation. And then they put half the group on traditional yogurt and half the group on, new improved probiotic yogurt. And what they found was that both groups regained approximately equal levels of their immune markers. But nobody regained their original level until they were allowed to resume their diet rich in bacterially diverse foods. People take probiotics, but I think anything you can get out of a little capsule, you can get better from food. And it just so happens that, fermented foods and these foods with live cultures are among the most, exciting delicacies that, culinary traditions all around the world have developed. Because of the war on bacteria and because, the earliest triumphs of the emerging field of microbiology involved identifying pathogenic bacteria, there's just a huge fear. And in the work that I've been doing, which is mostly just like teaching people how to make sauerkraut, teaching people how to make yogurt, the biggest question that I encounter, particularly in dealing with, sauerkraut and other things that are done as wild fermentations based on the organisms that are present on the food, is, is this fear that you'll get the wrong bacteria growing. So, everyone wants to know, how can I be sure that it's good bacteria growing and not bad bacteria? And just people don't want to hurt anyone. They don't want to get sick for themselves, and even more, they don't want to make somebody else sick. They don't want to, be a headline in the newspaper that the food that they prepared, accidentally killed their family or something like that. And so, there's just people are paralyzed by fear. And yet these foods really are among the safest foods that we know. In relation to sauerkraut, according to the U.S. Department of Agriculture, there has never been a single case of food poisoning documented in the United States from fermented vegetables. There are not many foods you could say that about. You certainly couldn't say it about raw vegetables, and yet, people rightly are not afraid of eating raw vegetables. But there's always the possibility of contamination. Usually it's manure from a factory farm uphill that runs over the vegetables. It could just as well be, people who don't wash their hands handling the vegetables. There's always the possibility of incidental contamination. But if you were to take vegetables that had been subjected to incidental contamination and ferment them, well, the indigenous population of lactic acid bacteria that is present on all raw plant material would dominate. And as those lactic acid bacteria began to acidify the environment, they would destroy the incidental pathogens. And this has been repeated in experiments time and time again as traditional practitioners, in order to sort of convince regulatory authorities that their foods are safe, intentionally inject them with known pathogenic bacteria, let them ripen, send them to laboratories, and they never can find any trace of the pathogenic bacteria that they have, inserted into the food. Acidification is an effective strategy not only for food preservation but for food safety. So anyway, there's a huge amount of fear, and yet. Especially as people have become more interested in local food, reviving, the idea of, regional food self-sufficiency and reviving markets for local food. In most temperate climates, if people want to feed themselves primarily on local food, fermentation has to be part of the picture. So, we kind of have to get over this fear that we've projected upon this ancient process, and embrace it as really as important as the seeds that are our cultural legacy from our ancestors that give us the foods that we love to eat. Fermentation is every bit as important a part of that cultural legacy. But in order to in order to use it, we have to we have to get over this fear of bacteria. Now, I mean, almost everyone I talk to has a memory of like a grandparent who had some sort of fermentation practice. Historically, fermentation just has been part of, every household and every community. But, as food production has disappeared from our communities, fermentation has largely disappeared. And so, there's been a break in the continuity of sort of, passing this essential cultural information along. And so, I think that people are waking up to this, just in the nick of time. While we still have, some threads connecting us to this information. And it's not that people have stopped enjoying fermented foods. I mean, still everybody eats fermented foods every day. By this time of day, even if people haven't eaten lunch, like, almost everyone's had something fermented. If they had some coffee for breakfast, if they had a piece of bread, if they had a piece of cheese. They're just so common. It's just that, rather than being practiced in people's home kitchens, it's disappeared behind factory doors. So anyway, I'm wondering whether there are any specific questions that any of you all have about, sort of big conceptual issues, or really specific, questions about, the mold on your sauerkraut or your yogurt or your kombucha or whatever. Right in the front.
It's about sauerkraut.
Okay.
Is it safe to eat after its expired date?
Okay. Is it safe to eat after its expired date? Food expiration dates are something that anyone who is manufacturing any kind of food is required by law to put on the food, and in many cases they are arbitrary. Sauerkraut evolved in the context of no refrigeration. Even without refrigeration, if you make sauerkraut in the cool part of the year and have an unheated space in which to store it, it will certainly last, with good flavor and texture up until, the following spring when you start to have fresh vegetables available again. In the context of a refrigerator, which really is a fermentation slowing device, I mean, that's why it is beneficial to us in our kitchens. A salty, acidic food like sauerkraut, if it's in a mostly full jar and submerged under liquid, you could pull it out 10 years later and it would be fine. Now, if it's dry, if it's in a jar with a lot of airspace, then you're likely to find molds developing on the surface, and then you would definitely want to get rid of those. And, if the molds have been growing for a long time, you might find that the texture gets really soft, and you might find eventually that the taste is compromised. But, if it's in a mostly full jar and kept submerged under liquid, there's nothing at, refrigeration temperatures that is going to, compromise the sauerkraut.
Thank you. I just made my first batch of kombucha, and after about 8 days, the mother got 3 small, whitish, bluish, brown mold spots on it. Do I have to throw it away?
Let me say yes and no.
Vinegar on top of it, because in your book, The Art of Fermentation, with regards to mold and kombucha, it basically says it needs to be acidic enough.
Yeah.
And so in my effort to rescue it, I just poured some additional raw apple cider vinegar on top of the mold, and you can still see the shape, but it's certainly not growing.
Yeah. Well, I mean, if you had sort of added that before, it probably wouldn't have grown the mold. If it's a whitish mold, just in general, white molds are benign. When you start saying whitish, bluish, blue molds can have more toxicity to them. Mostly based on the work on an essay written by Paul Stamets, who is a sort of popular mycologist from Washington State. He wrote this essay called My Adventures with the Blob about kombucha. And he had experiences of molds growing and identified some of the blue mold as an aspergillus mold that actually has releases compounds that are regarded as carcinogenic. Based on that, I mean, I would say better safe than sorry, and you should try to find another mother. And then the next time you make kombucha, do the acidification at the beginning, and then that will inhibit the possibility of molds growing on the surface of the mother.
I added mature kombucha and a little vinegar just to be on the safe side, but I think it might have been when I was poking it to see if the mold was forming. Maybe vinegar or something.
Yeah.
Containers would be ideal for fermenting in, and also what type of utensils, like wooden utensils or steel utensils?
Well, I mean, it sort of depends what you're fermenting. I mean, fermentation has given rise to all sorts of different amazing shapes of vessels. And so, for instance, when you're fermenting alcoholic beverages, usually once they're bubbly, you want to minimize the surface area. So you typically use what's called a carboy, which is like a water cooler container that's a narrow mouth. So you're minimizing the surface area where there's air exposure, which could lead to vinegar formation. Whereas, if you're making kombucha, you need something with a wide mouth. I would say in general, if you're doing, ferments that are going to be acidic, you want to stay away from metal. Because acids corrode metal, and also the salts that are used in most of the acidic ferments are corrosive to metal. So stay away from metal, glass, ceramic, wood. Plastic is functional, but probably not ideal. I think those are the materials, but the shape really depends on specifically what it is you're trying to make.
Just a follow-up question to that. Can you speak at all to specifically high-grade stainless steel for kombucha and kefir?
Yeah, sure. Household stainless steel just has the thinnest coating of a stainless coating. So I would definitely stay away from that. In the ferments you just mentioned, both are acidic ferments. But yeah, sure, if you were doing this on an industrial scale and wanted to invest in, industrial grade solid stainless steel, which would be, hundreds of dollars for a small vessel, you can work in solid stainless steel. And I know a lot of, fermentation businesses invest in vessels like that to work in. But at a household level, I think, glass and ceramic really make much more sense.
I've been making yogurt using whole milk for quite a while, and I was wondering, how can you make like a really thick yogurt with a high milk fat content, like something like with an 8%, like a thick Greek-style yogurt at home?
Okay, well, there's a couple of things. First of all, you have to heat up the milk. I'm not very good with my centigrade conversions, but I usually heat it up to 180 degrees Fahrenheit. And this Turkish woman who I met, counseled me to hold it there for 15 minutes. And so basically what you're doing when you do that is water is evaporating off of the milk. And so that's, so if you read yogurt containers, a lot of yogurts, they add non-fat milk powder to it. So if you just hold it at a warm temperature, you accomplish the same thing in a more traditional way of just like losing some of the water. And then, maintaining the proper incubation temperature is really critical for getting a nice thick yogurt. And a lot of the, commercial Greek yogurt products, after the yogurt is mature, they strain it. So they strain it through, basically tightly woven cotton. Put the yogurt in there, let it drip, and you'll have whey dripping out, and it will get thicker and thicker. So it's like, the initial rise in temperature, which denatures the protein and enables them to be reknit by the bacteria into a solid form. It's losing some of the water, and it's maintaining the proper incubation temperature so that the bacteria are, at their most active. And then if you want it to be even thicker, draining it so that you get whey dripping out of that yogurt, and it'll get it'll get thicker than yogurt. I mean, if you let it keep dripping, it'll become like a cheese.
Fermenting wild meats. Meats? Yeah, especially considering like food safety there.
Yeah. Okay. So. Okay, the limitation in fermenting meat is lack of carbohydrates. So, meat does not has only a negligible carbohydrate content, and carbohydrates are what ferment into acids and preserve whatever the food is. So, like salamis, which are also known as, fermented sausages, when the meat is ground, a little bit of sugar is added, and that gives the carbohydrates that enable the bacteria to produce acids that, contribute to the preservation of the meat. When you ferment a whole piece of meat, more in the style of a ham rather than a salami, there is fermentation, but it is more incidental and it contributes a little bit more to the flavor. But it is not what preserves it. When in a ham, it is it's basically the drying and the salting which preserve it. And so I would think that would be the same whether the meat is a wild meat or a domesticated meat. I mean, I would think all of the issues would be exactly the same for wild meat as they would for domestic meat.
I just mean especially because I know in the old days they used to basically salt the meat and have it in a big crock,
Well, okay, so just salted pork, salted beef, that's not exactly fermented. I mean, that is salted to such an extent that, it essentially sterilizes the food. It essentially, makes it impossible for bacteria to grow. The fermented meats are more moderately salted. So that you are only creating a selective environment, where some bacteria can continue to grow, but many of the bacteria are inhibited by the salt. But I mean, again, the issues would be all the same. In the Art of Fermentation, I have a whole chapter about meat fermentation, and also references to some more comprehensive resources about meat fermentation. But I mean, I can't imagine any reason why the issues would be any different for wild game that is sort of hunted or trapped than for pigs or cows or lamb or other domesticated meats.
Just to change the topic themes I'm questioning, I'm a health student here, you can see, and interested in maternal and child malnutrition. And some of the stuff you're talking about in terms of how bacterial cultures in the gut facilitate, well, they're very crucial for metabolic process and whatnot, but that also a mother's lactase and bacterial culture can affect the reproduction process. I've also heard lots of links in terms of a mother's diet affecting the innate, or I guess the preborn, or how good the bacterial cultures are in the child gut once they're born, and they're kind of not amenable to that much change in terms of what you can do about it. So I was curious to know if you know what kinds of foods are critical to be eating for a pregnant woman, and how those can affect, if fermentation has anything to do with that, or are there any things that you know that are interesting in that?
Yeah, I mean, I don't know. I really don't have like a nutritionist kind of a background, and I don't know of any specific foods that it would be critical for a mother to be eating. It's sort of like if she had healthy gut bacteria. And is eating foods that would support that. I mean, in addition to the notion of probiotics, there's also this notion of prebiotics, and that is, foods that, nourish the bacteria in our gut. And often those are very high fiber foods that don't get fully digested in the stomach, so they carry nutrients into the large intestines. And in at least one case, they are foods that I have often heard derided as being indigestible. Inulin is one example, and the food that is always cited as a high in inulin food is Jerusalem artichokes. Sunchokes, and the conventional wisdom is that you shouldn't eat them raw because they have this indigestible compound inulin that will make you really gassy. Well, if you go to another literature, it is the prime prebiotic that feeds the bacteria in the large intestine, and I would imagine that is precisely why people find that they make them gassy. But for a person that has a healthy, diverse gut microflora, just making sure you have plenty of high fiber foods will maintain the health of that population.
Malnourished population. What are the best foods to be eating to boost the microfloral bacteria?
Well, I mean, I would just say any of these foods that are rich in bacterial cultures, yogurt, sauerkraut, any of these. I'm very interested in this group of beverages that I would call sour tonic beverages, and the one that's sort of like become a huge fad is kombucha. But all around the world, people drink lightly fermented sour tonic beverages. Some of my favorite examples are in Russia, people drink kvass, which is basically, dry rye bread re-fermented. In the Caribbean, people drink mabi, which is a bitter-sweet sour soft drink. In Mexico, people drink tepache. In Brazil, people drink alua, and these are very similar lightly fermented fruit soft drinks. But any of these lightly fermented beverages, any of the fermented dairy products, any of the fermented vegetables, and eating these foods, eating lots of different bacterially rich fermented foods, I would say is the best way to, repopulate and diversify the gut microflora.
I'm fermenting a lot at home. I'm fermenting applesauce and making applesauce leaven. I'm just wondering about temperatures of the dehydrator to be sure that the bacterial is still, and is it still active if it's dry?
Yeah, sure. I think if you slowly dry something and keep it below 120 degrees, the lactic acid bacteria, they'll go dormant. Bacteria need available water in order to be active, but drying food won't kill them. It will, unless you do it at high temperatures, it will just sort of bring them into dormancy. So I would just say, on a low setting on your dehydrator. Well, with freezing, no. Sir, if you freeze sauerkraut and then thaw it, it still has viability. It loses potency with every freezing and thawing. You get a certain amount of cells bursting. So, the conventional wisdom when you're freezing a ferment is to dry it as much as possible. The less water content there is, the less expansion and contraction there will be. So, for instance, a lot of bakers like to freeze their sourdough. I would think of it like backing up your computer or something. Just so if somebody's like cleaning the kitchen and they're overzealous and they throw away their bubbling cauldron of sourdough, they have it backed up in a freezer. But it maintains much better potency if you thicken it up so that there's a lower water content than if you put it in a liquid batter kind of a form.
Do you have a favorite way of fermenting Jerusalem artichokes?
Jerusalem artichokes. I have mostly done them as part of a mixed vegetable sauerkraut or kimchi kind of a thing, and you can grate it or you can slice it, or you really could even leave them whole if you liked, as long as they get sort of submerged under the salty liquid of the rest of the vegetables.
Mine got a little bit weird and grainy after I went. Is that just something with me, or is that something that's
weird and grainy. I haven't noticed that.
Can you suggest any other ways to carbonate beer besides adding extra sugars? I usually add to take out extra level of yeast, but are there any other methods that you can suggest?
The only other method. Okay, so that's like when you add sugar to beer or to wine at the bottling stage, that's to create a controlled amount of fermentation in the bottle, so you get carbonation of your beer or of your champagne. The only other way I know of, besides adding some priming sugar at the bottling stage, is to use a carbon dioxide tank to do it. You could use other kinds of sugar besides dextrose if you wanted, but no, that's the only way that I know of to do that.
I've been doing kombucha for about a year, and been really on top of it, like every 7 to 10 days, making it fresh brew. But as it's happened in the last 2 or 3 months, I haven't been able to. So my brews have just been sitting. They're nice, really thick scobies. They don't have any visible mold on it, but it's really evaporated down. I'm just wondering if that liquid that's in there, is it still safe for me to make another brew out of that, or should I?
Yeah, I wouldn't worry about the safety of it. It's just going to be intensely acidic. It'll be like vinegary. But no, I wouldn't worry about the safety at all. In a way, the more acidic it is, the safer it is. So no, I wouldn't worry at all about that. And let me just decipher that acronym that he just used, SCOBY, SCOBY, Symbiotic Community of Bacteria and Yeast. And that's that's the generic name that we use for a kombucha mother, which is this sort of like rubbery pancake-looking layer that forms on the top of kombucha and gets thicker and thicker, and it can be anywhere from a thin film to many inches thick, and you can peel off different layers that represent the different generations of batches. Kefir, which is a milk ferment from the Caucasus Mountains, has a SCOBY that is generally called kefir grains or kefir curds, and they look like little florets of cauliflower. Then there's something that's frequently confused with kefir that has become known as water kefir. Comes from Mexico, where it's called tibicos, and it's a more granular, little opaque crystals that can ferment fruit juice or sugar water or really any kind of carbohydrate liquid into a tonic sour beverage. And then there's a couple of others that are more obscure, but what they all have in common is that they are communities of microorganisms that generate a macrophysical form that we can see and hold. And they're really of very much interest to evolutionary biologists because, they really are evolved life forms that have evolved in relatively short time. Kefir in particular has just been studied a lot because, it has only been possible since humans have been collecting the milk of domesticated animals in vessels. And so, this is a really elaborate life form that has evolved in a very short, relatively short period of time. Did you have a follow-up to that? Or?
Yeah, the sugar water kefir that you mentioned, I use things like crushed up eggshells and jaggery and cane sugar. What other things can you feed that culture?
Fruit juice, different fruit flavors. A lot of people do it as a two-stage ferment. So they'll do like the sugar water, on the water kefir grains, and then they'll drain that off, and then they'll mix, different kinds of fruit juices or different kinds of herbal flavorings. I even had a coffee-flavored watered kefir soda that somebody made last year. People are taking it in all sorts of, innovative directions.
Does sauerkraut have to be salty?
Does sauerkraut have to be salty? No, it does not have to be. You can make sauerkraut with no salt at all. If you've been convinced that one more grain of salt is going to be your demise. I would say that like sauerkraut with no salt doesn't taste very good. It doesn't have a very pleasing texture. It won't last for very long. I think you're much better off with a very small amount of salt. The problem is that, in their traditional context as survival food in places with short growing seasons, people who have had access to salt have tended to make them extremely salty. If this is going to be the only fresh vegetable that you're going to, or the only vegetable that you're going to have over the next, 8 months, you kind of have an incentive to put a lot of salt in it. It doesn't need a lot of salt, but just a little bit of salt will help inhibit the enzymes that will digest the pectins and make it mushy. Like that's my complaint with the salt-free krauts that I have had, is that they just, within a week or so, they just are like baby food. The crunchiness, the resistance of them disappears. So you can make good sauerkraut with just a tiny bit of salt, but I think a tiny bit of salt is much better than no salt. But absolutely, you can make it with no salt. The best no salt kraut I ever had used celery juice over the vegetables. And celery is a very mineral-rich vegetable, so it sort of provided certain of the benefits of using salt without having actual refined sodium chloride in it.
I don't know if you had a boundary of the kinds of questions you get, but in well fermentation, you're very open about your HIV status and about taking heart medication. I'm a nutritionist, and I'm always wondering about, if do you believe that eating all of fermented food and eating really healthy food, do you think it could substitute the medication?
No. It wouldn't do the same thing as the medications. There are people who remain very healthy without medications. I had a health crisis that, sort of convinced me to go on meds that I didn't particularly desire to go on, and I've been on them for, 14 years now. And my health has been, relatively good. I wrote on the back of Wild Fermentation that fermented foods had been part of my healing. And you wouldn't believe what people would take out of a vague statement like that. So, I mean, I've read articles for myself about myself where people have said that I claim that I cured AIDS with fermented foods, and I haven't. So I have become very wary of people's claims of specific foods' ability to cure different diseases. So even though I mentioned that fermented vegetables have this anti-carcinogenic compound in them, that doesn't mean that if you're diagnosed with a brain tumor, all you have to do is eat a pound of sauerkraut every day and your brain tumor will go away. Arguably you'd be less likely to develop that problem in the first place if you were eating it, but probability doesn't mean it can't happen. So I just think by improving digestion, improving nutrient availability, improving overall immune functioning, anybody has the potential for their health to be, improved by incorporating live culture foods into their diet. And we don't need to make miraculous claims. And if someone can stay healthy with HIV for decades and don't need to go on the drugs, more power to them. And if someone can cure their cancer through diet and lifestyle alone, more power to them. But I don't think that it's reasonable to expect specific foods to sort of cure all of our disease processes. And so I don't really think that taking the meds and and eating well are related. I will say that a lot of the people who I meet who take the kinds of drugs that I take, do have chronic digestive problems that they relate to them, and I've never experienced any of that. But still, I am on these drugs.
Some recipe calls for mixing in the mold that grows on top, and others seem to remove it. And I was just wondering if there was any specific reasons why it was fine to keep it in some cases and other cases not to.
Well, a food like fermented vegetables, which, really everywhere across the Eurasian landmass in the sort of northern parts, everywhere people do this. And they do it in different kinds of vessels with different kinds of philosophies. And there's a lot of contradictory ideas that come out of different cultural traditions. And I skim it off unless I'm making a liquid form, I do some liquid infusions of vegetables. I make this thing called beet kvass, which is a liquid infusion, and sometimes some white mold grows on top of that. And I've just found that it's kind of impossible to effectively remove all the little powdery mold on top of the liquid. So I end up just shaking it in. When it's on solid vegetables, it's actually much easier. It results in a little bit of food waste. You have to sort of skim off the very top layer. Sometimes people will put in cabbage leaves or something as a barrier on the top to make it easier to remove, and so that there's less waste of the food that you're really after to eat. But it's just I would say it's different aesthetic ideas about food, and especially if the molds are. If the molds are white, they are benign. They're safe. You could eat them. Even if you scrape them away, usually it's impossible to get every last bit of it, and you'll get little pieces of it dissipating into the brine. And so, those I would say mix in, don't worry about. But personally, my aesthetic sensibility is that I prefer to try to remove the mold as much as possible. But I think that's why there's contradictory ideas. Is just this is not a there isn't uniform. Is there uniformity to how you boil an egg? There's no uniformity about any form of food preparation, and anything that is anything that is sort of widespread, there just end up being a lot of different ideas about how exactly you do it. And, ultimately a lot of it comes down to family recipes. Here's a little example is, for the most part with any food that you're aging, you want to keep it out of direct sunlight, if only because sunlight, degrades nutrients. And this man in his 80s who lives outside of Washington, D.C., sent me this long email telling me about his Romanian-born mother's pickle-making methods. And one thing that she did with her pickles is she always put the crock right in the window, and she wanted the sun to shine on it. And her idea that his methodical experimentation had confirmed was that the UV rays would prevent mold from growing on the surface. So there are trade-offs. Maybe you get a little bit of nutritional degradation that a layperson would have no way of measuring, but you avoid the surface mold. So people just end up valuing different qualities or so I think that's why you find different ideas in different recipes and different traditions.
The difference between using an open crock and something like a sealed jar, like a pickle jar?
Okay, I mean there are lots of different kinds of vessels. There's a little bit of there's a little bit of a debate going on in the internet right now. These people advocating a very cleverly designed system for making sauerkraut. They're calling it the pickle-it jar. I think it's been available for 2 years. And it's a sealed vessel. There's certain advantages to a sealed vessel, which, you can't just, put sauerkraut in a jar, seal it, and forget about it, because it creates carbon dioxide and it needs a way to get out. So, in most places, historically, they've worked with, open vessels of some sort, and so there's air exposure at the surface, and you have to scrape away the mold that grows. The pickle-it is a clever design that enables the carbon dioxide that's formed to get out without letting fresh air and oxygen in. So if it's used properly, you can avoid the phenomenon of surface growth, which can include not only molds but yeasts. And the proponents of the pickle-it online are being quite shrill and trying to make people think that it is unsafe to make sauerkraut in an open vessel the way people have been doing it for thousands of years. That only the way that they thought of 2 years ago can make safe sauerkraut. So I have no criticism of their cleverly designed vessel, and there are also these airlocked vessels that are manufactured in Germany called harsh crocks that have a rim around them that you fill with water, and you put the lid in the rim, and so the pressure inside sort of burps out, but the lower pressure air from outside can't get in. That's a great design. I have never found them to be effective for me because I am obsessively interested in smelling and tasting it as it develops. And every time you open it up to smell it and taste it, you're defeating the purpose of your clever airlock. So I just don't worry about it, and I like to use an open vessel that I can see in and smell it and taste it. But again, these are like aesthetic considerations, and there's lots of different vessels, and if you're really freaked out by molds, then maybe one of these airlocked solutions that prevents the possibility of molds is a good solution for you. In terms of refrigeration, the context for sauerkraut and all the other ferments is that there is no refrigerator. So, so if you have a cool place to store it, you really can do this without refrigeration. However, people have different tastes, and a lot of the contemporary directions for sauerkraut say fermented for 2 or 3 days. The harsh crock directions say 2 or 3 weeks. In the agrarian tradition, it would be at least 2 or 3 months. So all of these are possible lengths of time. The thing is that the flavor changes over time. Acids accumulate over time. That's why, extra sharp cheddar cheese is usually more expensive than mild cheddar cheese, because it has to age for longer, and time is money in our culture. But the thing is, some people prefer mild cheddar cheese to sharp cheddar cheese, and some people prefer mild sauerkraut to sharp sauerkraut. So, the great thing about living with a refrigerator in terms of making sauerkraut is, when it reaches the acidity that pleases you and you don't want it to go any further, then you could move it into your fermentation slowing device. And so, you can maintain, the flavor of a 3-day sauerkraut if that's what you like. So I hope that answered your questions.
I'm a little bit confused about how there's some discussion about how body systems need to be either acid or how they balance. I'm interested in how the lactic acid forming foods play into that.
Yeah, this is a question that comes up almost everywhere. Like there's this acid alkaline analysis of human health, and people on contemporary I'm used to calling it the standard American diet, but I'm trying to not be so U.S. centric. But people who eat a lot of sugar and carbohydrates, tend to be overly acidic. A lot of that is due to demineralization, because the minerals are alkaline. So eating things like sauerkraut, which are acidic, because they make the minerals in the food so much more bioavailable, they actually have the net effect of alkalinizing our bodies, even though the foods themselves are acidic. And it's a little bit counterintuitive, but sometimes acidic foods actually have an alkalinizing effect in our bodies.
I was wondering if your fermentation patterns ever extend past food to things like compost or compost tea or bokashi.
Yeah, totally. I mean, in my new book, The Art of Fermentation, the last chapter is called Non-Food Applications of Fermentation. I'm really interested in compost and all the different sort of theoretical approaches people have to compost. Actually, a friend of mine who has a big 300-acre farm near where I live in Tennessee. I've been after taking a workshop with this soil microbiologist, Dr. Elaine Ingham. I've been sort of making these in a big 250-gallon brewer, making these huge batches of compost tea that they've been spraying around the farm, and they're growing corn, which they're turning into moonshine, corn whiskey. And when we started doing this, and they have an organic certification, and when we started doing this, all the old guys who are the traditional local corn farmers were just shaking their heads skeptically, imagining that you couldn't possibly grow corn, without fertilizers. And now, just a couple weeks ago, this old farmer guy who I met was like, "Oh, you're the guy who makes that compost tea? I want to learn about that." I think that fermentation is a hugely important, natural phenomenon, and microbial decomposition. We talk a lot about the cycle of life and death, but it's really the cycle of life and death and fermentation. And without microbial decomposition, we would have huge accumulations of dead plant and animal matter on the earth. So I think that it's an important, a hugely important, part of the cycle, and and that it's being harnessed in lots of different ways. I mean, the fiber arts incorporate fermentation. There's a word redding. Redding is what you do to to get flax fibers out of the plant, to get hemp fibers out of the plant. Redding is the Dutch word for rotting. It's basically just moistening down those stalks and letting the microbial processes run their course, and then you can liberate the fibers. Certain kinds of dyeing of fibers incorporate fermentation, particularly the indigos. In seed saving, for tomato seeds, fermentation is essential, and for many other, vegetables that are fruits, fermentation is a way that some people use to save the seeds. There's many, applications of fermentation, beyond food that people eat, and yes, I'm interested in them all.
I'm just about to start my first try at making natto, and I went online, and there seems to be more, in some of the instructions, there seems to be way more concern about having a very sterile kind of environment in preparing it, more so than some of the other herbs I've been using. Is there a reason for that? Is there some toxic or poison that is more...
I mean, I would say that just in general, in the contemporary literature about fermentation, a lot of people emphasize sterility. Most notably, if you read the hobby literature for beer and winemaking, just everything is about, chemical sterilization. I mean, I would argue that, in our homes, outside of laboratories with really kind of extraordinary equipment to create sterile environments, it is not possible to create sterile environments in our homes. When you look at traditional natto production, it was done in rice straw. Okay, that is not sterile. I don't think, I learned a lot about natto from making tempeh. Okay, so, tempeh is completely different food from natto, except that they're both based on soybeans. So when you make tempeh, you, first you crack the beans in half, and then you soak them, and then you cook them for, not until they're really soft, but till they're, just for half an hour till they're a little bit soft. Then you drain it, cool it down, then you introduce the inoculant, mix it all up, put it into whatever kinds of forms you're using, and then put it in, I created this incubator out of a non-functioning commercial refrigerator with a light bulb at the bottom and a thermostat at the top. So it keeps it at 85 degrees Fahrenheit. Sometimes in my refrigerator, I put as much as 40 pounds of tempeh. And sometimes when I fill it up, what happens is in the middle of the process, it starts to generate heat. And so sometimes what I've done is accidentally killed off the tempeh with the heat that it produces by holding it in too small of a space. Whenever I have overheated the tempeh, it suddenly smells like natto, and then I run my finger across it, and it's got little strings like natto, so it reverts to natto. So basically, natto happens. Unless you pressure cook your beans, Bacillus subtilis, the bacteria that creates natto, is on the beans when they're growing. And when you boil them at, boiling temperature that just, reaches, 100 degrees Celsius, it does not kill Bacillus subtilis. When it's stressed by heat, it creates these spores that can survive hotter temperatures than that. So, so natto is easy to make. I just think in general, you don't need to worry about sterility. You want to work with clean equipment. If you're using your hands in the food, you want to be sure your hands are clean. But beyond, just common hygiene and cleanliness, we don't need to stress ourselves out worrying about sterility. I feel like that comes from the same place of fear that just imagines that the fermentation is dangerous. But the thing is that whatever, you wash your dish that you're going to make the natto in, it's sitting in your drying rack. Whether you use sterilizing chemicals or not, while it's sitting there drying, bacteria are landing on it. And those random bacteria that land on it are not in a great enough density to challenge the the organisms that either you're introducing or that are indigenous to the food. So you just don't need to worry too much about incidental bacteria in the environment. That would be my response to that. So let me just take 2 minutes to just kind of like wrap things up. So I just want to talk a little bit about language. And so the word fermentation comes from Latin fervere, which means to boil. And actually the word yeast comes from Greek zestos, which means to boil. And it's because the visible action of fermentation in liquids is bubbles, the same as the visible action of boiling in liquids. But there's this whole other connotation of the word fermentation. And, people talk about social ferment, cultural ferment, political ferment, intellectual ferment. Even I've seen spiritual ferment. And this is basically a metaphorical application of the idea of bubbles. So when people get excited about ideas, whatever those ideas are, they get bubbly. And, when you get bubbly, you want to talk about the thing that you're excited about, and you want to share the idea. So this is the sense in which, fermentation is an engine for social change, because, things don't change if people don't get excited about ideas and, excited about, the possibility of change and start believing that change can happen. So I just want to sort of, leave you with that sort of, metaphorical notion of fermentation. And want to encourage you all to sort of go out and be like seed cultures and spread these ideas so that they can grow. Thank you very much.